Top of the morning, everybody. The topic of today is Sigma notation, grade 12. And please, welcome back to Renalwena Education. We're gonna deviate from this important example first, then I'm gonna explain what we mean by Sigma notation. All right? Please bear with me. Consider the following series, okay? This is an arithmetic series. But we don't have that surety that this is an arithmetic series. We gotta check first, all right? We gotta confirm. They say trust but confirm, all right? So this is 3, 6, 9, 12, all the way up to 186, okay? Now, we gotta check what type of a series is this one. Intuitively, we can see that this is just an arithmetic series. But let us confirm. Now, 6 minus 3, it's how much? 6 minus 3, it's 3. All right. 9 minus 6 is how much? It's 3. 12 minus 9 is how much? It's 3. So we see that we have a constant common difference. We have a constant common difference there. We have a constant common difference. That means that we have an arithmetic series here. This is arithmetic. All right. Now, the first question, find the general term of this series. That we know that is an arithmetic series. We can just find the term like so. We're going to say our general term, Tn equivalent to A plus n minus 1 times what? Times D there. What is our first term? Our first term will be 3 plus, we don't know what is n. What is D now? We know D, it's 3. It's our constant common difference. So that's 3. So this is true even only if we have Tn being equal to what? We will multiply through by this n, by this 3. 3 times 1, 3 times n. So we have, let me write it like so. We have 3n minus 3 plus this 3 here. So our answer, it is just 3n. Our answer, it is just 3n. So this is how you solve this one, all right? This is how you solve this problem. Now, number 2, find the number of terms for this series, okay? We know the last term of this series. We know the last term. Our last term is 186. We also know the general term of this series. Now, we can just find number of terms. So number of terms, we will say the last term is 186. Then we know that our general term is 3n. We will divide both sides by 3, like so. Therefore, our n, 3 goes how many times to 186? It goes 62 times. So that means it shows that we have 62 terms and also 186. It is term number 62. All right. It shows that we have how many terms? We have 62 terms and 186 is just 62 term number 62. Sorry, term number 62 there. All right. Now let us go to number 3. Express the above series in sigma notation. Now we start. The sigma notation. This is the sign for sigma notation. It means sigma. It's a Greek letter, sigma, and it reads as what? As sum. Now the contents contained in what? In sigma are these ones. We have n, which are what? Number of terms, which is just number of terms. Then Tn, it's your general term. Then your I, it's your index. That means it's your starting position. I'm going to explain this further using examples. Let us start with our cases first. We have 2 cases which are involved in sigma notation. Your case 1, they say if I, your index, it's 1. the number of terms it is equivalent to how much? Number of terms it is equivalent to n. Number of terms it is equivalent to n. What do I mean by that? Let's suppose we had sigma of this form, sum of 15 terms all the way up to 3i. Now they say find number of terms here. We see that we have 15 terms. Your position starts from 1, then your general term is 3i. Now, how can you find number of terms here? We will find number of terms because we know that case 1 says that if I is equals to 1, then number of terms is equals to n. So that means our number of terms is just 15. So since we know that I is 1, then n is equals to how much? 15. So number of terms is just 15. Are you happy with this? Can I get an amen for this? Can I get an amen? So please let's continue to case 2. Case 2, they say to us if I is greater than 1 or I is equals to 0, the number of terms is equals to how much? So I'm going to show you this in a bit. Let's say we have sigma 15 terms. Now let's say your I is 0, then you have your 3i there, which is your general term. So now we can see that this is your number of terms, this is your position, then this is your general term. Now number of terms will be equivalent to top minus bottom plus 1. Why is that? Because I is greater than 1 or I is equals to 0. So I is 0, so that means your top is this one. This is your top, then this is your bottom. So you're gonna say top, that means 15 minus what? 0 plus 1. That means we get how many terms? We get 16 terms. All right, since I is equals to what? Since I is equals to 0. Let us check if your I is just number greater than 1. Let me just say sum of 15 terms. Let's say our I is 3, then this is your 3i there. So we're gonna say since I is greater than 1, then n is equivalent to how much? You're gonna say 15. That means your top minus your bottom. Your bottom is 3 plus 1. So 15 minus 3 is how much? 15 minus 3 it's just 12. Then 12 plus 1, we have 13 there. We have 13 there. So that means we have 13 terms. So number of terms, it is not 15, it is just 13. And we can just confirm this by doing this. Let me say we had something like this. Let me say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 9. So let me say 10. 10 plus 11 plus 12 plus 13 all the way up to 15 there. All right, now they say our position is how much? Our position is 3, meaning we will start from position what? We will start from position 3. All right, so if you start from position 3, we exclude these terms, we exclude those terms. Now how many terms do we have now? We will minus 2 terms. If you minus 2 terms from 15 terms, we will have 13 terms. So this is what we mean by this. All right, so I hope you understand what we mean by that. Now let us continue to important example 2, where we evaluate this sigma annotations there. Now evaluate the following. So we have 15 starting from 1 all the way up to the general term of 3k plus 5. Now we gotta evaluate this first. The first step, we do not know what type of a sigma notation is this one. We don't know if it's arithmetic or it is geometric. Now we gotta confirm. We will confirm by evaluating this first. How can we evaluate this one? I'm going to start by saying 3 into, we start from position 1, plus 5, plus how much? 3 into 2, plus 5, plus 3 into 3, plus how much? Plus 5. Now 3 times 1, it's 3. 3 plus 5 is just 8. Plus 3 times 2, it's 6. Then 6 plus 5 is just 11. 3 times 3 is how much? 3 times 3, it's 9. Then 9 plus 5 is how much? It's 14. Now we need to check if this is arithmetic or geometric. Now I'm going to say 11 minus 8. So 11 minus 8, it's just 3. 14 minus 11, also 3. So this actually confirms that this is your arithmetic series. This is arithmetic. This is arithmetic series there. Now let us use what we have to find the sum. Now we will use the formula, this formula. This Sn being equivalent to n over 2 into 2a plus n minus 1 times d. It is also equivalent to sigma of n terms starting from position 1 all the way up to tn there. I hope you understand that these two things are the same. All right. Now let us solve. Let us solve using this formula of Sn. So how many terms do we have here? We have 15 terms. So we know that since I is equivalent to 1, then number of terms, it is just 15. So sum of 15 terms, it is equivalent to 15 over 2 into 2. What is a position? Term number a is just 8 plus 15 minus 1 times the difference of 3 there. Times the difference of 3 there. Now let us solve this one quickly. 15 over 2 there. 2 times 8, it's just 16 plus 15 minus 1 is 14. Then 14 times 3, it's 42. So we have 42 here. All right. So now 16 plus 42, I get 58. Now I'm just going to say 15 times 58. It will be 870 divided by 2. So therefore, our Sn, or sum of 15 terms, will be 435. It's just 435 there. So I hope you are happy with this one. I hope you are happy with this one. This is how we evaluate our important example 2 there. Now let us check important example 3. Please pause the video and try important example 3. Please pause the video and try important example 3. I hope you have attempted important example 3. So this is how we solve it. Sorry about that. This is how we solve it. Now, we can clearly see that our position is 3. All right, it doesn't start from 1. So I'm going to start with that note first. So my solution, I'm going to say since I, it is greater than 1, because it's 3, so it's greater than 1, then n, it is top minus bottom. So this is our top, this is our bottom. So top minus bottom, 8 minus 3 plus 1. So 8 minus 3 plus 1, we get how much? This is just 6 there. So number of terms is 6. Now, I'm going to evaluate this one. I'm going to say 2 into 3 plus 1 plus 2 into 4 plus 1 plus 2 into 5 plus how much? Plus 1 there. All right. So 2 times 3, it's 6. So 6 plus 1 will give you 7. Yes. Then 2 times 4, it's 8. Then 8 plus 1 is just 9. 2 times 5 is 10. Then 10 plus 1, it is just 11. So we have your series there. Now, let us check what type of a series is this one. So I'm going to say 9 minus 7. 9 minus 7, I get how much? I get 2. Then 11 minus 9, I get also 2 there. Now, this confirms that this is your arithmetic series. This actually confirms that this is your arithmetic series there. Now, let us continue and find the sum. So we know that we have 6 terms. So I'm going to say sum of 6 terms, 6 over 2 into 2, what is A? 7, what is N? Your N is 6. We have 6 minus 1 times the difference of 2. So 6 divided by 2, it's 3. 2 times 7, it's 14. Then 6 minus 1, it's 5. Then 5 times 2, it's 10. So it's plus 10 here. All right. So 14 plus 10, it is 24. We have 24 times 3. So 24 times 3, we get 72 there. So sum of 6 terms, we get how much? We get 72 as our solution there. We get 72 as our what? As our solution there. Are you happy with this? Are you happy? Can I get an amen for this? Can I get an amen? Thank you so much. Let us proceed to another example. So please pause a video and try this one. Pause your video and try this one. I hope you have tried an important example 4. It says determine the value of m if you have this. This one we gotta be careful, all right? We gotta be careful with this one. It's tricky. Now, we're gonna start by this note first. Solution. Since I is equals to 0, since I is equivalent to 1, 0, then our number of terms will be what? Sorry, will be top minus bottom. Top, which is your top there. Then this is your bottom minus bottom plus 1. So that means you have m plus 1. That is your what? That is your number of terms. All right. That is your number of terms, m plus 1. Now we evaluate our series. We need to check what type of series is this one first. So I'm gonna say 1 minus 3. What is I? 0 plus 1 minus 3 into 1 plus 1 minus 3 into 2. So 3 times 0 is just 0. This is 1. Sorry, I'm gonna do this here. Yes. So 1 minus 3. We just gonna have minus 2 here. Then 3 times 2, it's 6. Then 1 minus 6, we have minus 5 there. All right. We just have minus 5 there. Now let us check what type of a series is this one. I'm gonna say minus 2 minus 1. I get how much? Minus 3. I get minus 3 there. Negative 5 minus 2. That means it's minus 5 plus 2, so we get minus 3 there. So it tells you that this is just arithmetic series. This is just arithmetic series. Now we have what we need. Now let us find the sum. Sum of m plus 1 being equal to m plus 1 over 2 into 2. What is our a? Our a is 1 plus, what is your n? M plus 1 minus what? Minus 1 there. Times your difference, which is minus 3. Are you happy with this? So this is your number of terms. Let me just put this into our brackets. This is your n, m plus 1 minus that. This is your difference, which is minus 3. Then we have what we need. All right, let us continue. So m plus 1 divided by 2 into 2 times 1 is 2 plus, here we have m. We just have m here because 1 minus 1 is 0. So we have m times negative 3. Then we close our bracket. Now if we continue, we have m plus 1 divided by 2. Then this is 2 minus what? Minus 3m. We close your bracket like that. All right. Are we happy with this? Are we happy with this? Are we happy? Now you have your m plus 1 divided by 2 into what? Sorry, let me just do this. We know that sum of m1 is s m plus 1. We know it is equivalent to this number. All right. So that means we know that sm plus 1, it is equals to negative 671. So we will substitute that here. We have negative 671. We will multiply both sides by 2. So I'm going to times by 2 this side. I'm going to times by 2 this side. Times by 2, then times by 2 there. All right. So now 2 times 671, we get 1342. Negative 1342. Then this will cancel that. All right. This and that will cancel away. Then we have m plus 1 times 2 minus 3m, like that. Are we happy? Are we happy? So this is how we solve this one. Now we will continue. We have negative 1342, which is equivalent to how much? Which is equivalent to, let me rewrite this one like so. I'm going to have m plus 1 times negative 3m plus 2. So let me multiply through here. I'm going to say this times this, that times that, that is m times negative 3m. I'm going to have negative 3m squared. M times 2, I'm going to have plus 2m. I'm going to say 1 times this, I'm going to have minus 3m. I'm going to have 1 times 2, sorry. 1 times 2, I'm going to have plus 2. Are we happy with this? Please be careful. Be careful with this type of calculations. You might make mistakes. You need to use FOIL method, all right? So we have negative 1342 there. Now let us group like terms. We see that here we have negative 3m squared. Then 2m minus 3, it will be minus what? Minus m plus 2. We take this that side. This is plus 13 4 2. You have your 0 there. I like to clean up. I like to clean up the mess. So for me to clean up the mess, I will divide through by negative. So now 0 equivalent to 3m squared plus m plus, this is just 1344. 1344 there. Let us use our quadratic formula. Let us use our quadratic formula there. So using our quadratic formula there, I'm going to have m equivalent to negative. So let's say this is A, B, then that's your C. So negative, what is B? Our B is just 1. Our B is just 1 plus or minus the square root of the discriminant. I'm going to have 1 squared minus 4. My A, it's 3. All right. Then my C, it's just 1344 there. My C is just 1344 there. All the way, all over how much? All over how much then? 2 into what? Into A. Your A is 3. Now, can we do it from here? I think I see our hiccup. Here, it clearly shows that our discriminant will be negative. Now let us see where did we go wrong. Let us check our solution, because I see that if the discriminant is negative, then we will get non-real solution here. Now let us check. From here, times by 2, we have 1342. Then we have m plus 1. Then there we have 2 minus 3m. So now m, this times this times this guy is negative 3m squared. That times that we have 2m. Then this times this, it's minus 3m. Then that times that is just plus 2. So we have 0, we have minus 3m squared. Then 2m minus 3m, it's negative m, plus, then this will change sign. It goes that side, it's this one. We have it here. So 2 plus 1342, it is just 1344. Now we have negative 3m squared minus m plus 1344. Yes, my mistake is here. You can see the mistake here. Since it's positive, if we divide through by negative, then I'm going to have negative there. All right. So that means we have your negative there. You just missed that negative. Please make sure that you confirm your solutions, because you might get things wrong. All right. You might get things wrong. So let's continue. I'm just going to use my calculator here. I'm going to say negative of 1, the square root of 1 squared let me use a calculator here. 4, then please bear with me. I do not like to use a calculator, but for this one, because it will waste my time, then yeah, I'm just gonna do it using my calculator. Please make sure you have 2 hours of maths every day. Please make sure you have 2 hours of maths every day. It is extremely important that you have 2 hours of maths every day, so that you can learn this, love this, and use this. All right, you gotta learn it, you gotta love it, and you gotta use it. Okay, They say to us, understanding comes from doing. Understanding comes from doing. So if I choose a negative sign here, I get my m as how much? As negative 21,33. If I choose my m as positive there, sorry, m as positive, I get m as how much? I get my m as positive, then I get my m as 21. So that means you need to know that our n, number of terms, are element of natural numbers. This entails that our m, it is 21 because we are looking for natural numbers, counting numbers, okay? This won't work, all right? This won't work. Suppose if your n, your value of m was 21,5, all right? So we want whole numbers. We want whole numbers, or I can say counting numbers. So this should be 22. You need to convert this to a whole number. All right. We do not look for a decimal numbers. We just want whole numbers when we deal with what? With n there. All right. Let's say it was 21,05. So that means this is just 21. All right. This is just how much? 21 there. All right. So please make sure that you know this off by heart. Make sure that you rewrite and redo these questions. And I hope you are happy with this session. I hope you are happy. We have covered sigma notation. And in the next video, I'm going to do what we call sum of n terms. All right. I'm going to do what we call sum of n terms. Then we move straight to geometric series. We move straight to geometric series. I hope you are happy with this, and please, I'll see you in the next one. Good luck.